OGC API records. So this will be the natural replacement for CSW, for that you might perhaps know from the first generation of web services, and it provides discovery and access to metadata about geospatial resources. OGC API records provide two main building blocks. One is the record collection, and the other one is the record itself. So basically, the collection is used to describe a collection of resources. So the collection of resources could be a collection of records, which we often call a catalog, but it could be also a collection of another type of resource, like a feature or a coverage. And the record provides a description or provides metadata about a given resource that the provider wants to expose. So basically, this will be the atomic unit of information in a catalog. The records in OGC API records is provided with a very basic, simple schema, but that is designed to be extended. So you could extend this schema for particular use cases, particular communities. Although this is still on the work, there's already some work going on in terms of aligning OGC API records part 1 with the Stack API. So it is expected that in the future we will see something similar to OGC API features, so that the two specifications are aligned. So based on these building blocks that I mentioned, there are 3 deployment patterns that are envisioned for OGC API records. So the first one is what we call a crawlable catalog. And if you are familiar with Stack, this will be the equivalent to a static catalog, which is basically very easy to implement. So you can have a set of files in a server. These files could be, for instance, satellite imagery, but it could also be feature data or something else. And they are sitting on a web server or in an S3 bucket. And each one of these, so there is a file on a top level which provides information about the collection. And these links to record files. Each one of these record files provides some metadata about each one of the resources that we want to expose. So the encodings could be in JSON or in HTML. And this is very easy to implement because basically you just need some location which is accessible on the web. As I mentioned, it could be a web directory, it could be an S3 bucket, and then you need to input there these description files, these metadata files, along with the resources. So this is a deployment pattern that provides mostly discoverability. It does not provide a lot of functionality to query the data, or to not say none. So you cannot do temporal queries or spatial queries. You're very limited in terms of things that you can do, but it's a very easy way to expose some files, some data that you have stored somewhere with a bit of organization. The other pattern, which is more sophisticated and it's closer to what we expect from a CSW service, is the searchable catalog. So in this case, we have something that is, we have a structure that is similar to what we already saw in OGC API features. So we have a landing page, we have a conformance declaration. So it's a full-fledged OGC API. And in this case, the collections, as I said before, they could be collections of records. So it could be collections of records, and from there you can access each record. We can implement also the additional query capabilities. So for instance, the sort, the query parameters, the SQL, and so on. And then you are enabling a search, what we call a searchable catalog. So a catalog that can be queried with a certain degree of sophistication. In terms of encodings, we can support also JSON or HTML, but also Atom. In terms of implementation, I mean, in order to support these, we typically need a database backend. So the database could be a relational database like Postgres, but it could also be a NoSQL database. It could be, for instance, Elasticsearch or MongoDB. And if you look at the PyGeo API, which we're going to see in a moment, you can see that PyGeo API supports different databases backends.